right, yeah.
So you would have, so if you had something like this as an aside,
Okay, I kind of get it.
if you had that, then you'd have
It's in the center, right?
I12 there. Okay. But if you just have a disk on a plane, that's where the instance center is. I'll see if I can remember to look at a better explanation. So we did 2 bodies here. Let's do 3 bodies. So with 3 bodies, we have, let's draw a gear train or gear pairing. All right. So the grounds here are labeled as 1. The pinion is 2, and the gear is 3. Okay? So if I look at this right here is I12. This right here, why don't you guess what this one is? What do you think this one is?
I23.
1,3, yeah. So there's another instance center on this. Where do you think that is? Where they touch, yeah. That's actually called the pitch point. So this right here, what do you think this one is labeled? I what? 2,3. Okay? So that's I23. So what I want you to note here is we have for 2 bodies, we had, if you look back at this, for 2 bodies, we had 1 instance center. For 3 bodies, we have 1, 2, 3 instance centers. And then you can extrapolate out from this for n bodies. We have n times n minus 1 divided by 2 instance centers. Okay? And this is the basis for 3 instance centers. They all have to lie on the same line. So let's look back at this thing here. It's all in frame here. So on this here, we have I12, I23, I13, and it's not a coincidence that all these instance centers lie on the same line here. Okay? And that is the basis of this thing called Kennedy's theorem. Alright, so this guy Kennedy, I guess, observed that and came up with that equation. So let me do an example, and we'll end with this example for today. For a 4-bar mechanism, apply Kennedy's theorem to locate all instant centers. let's go ahead and just draw a 4 bar. Yep, sure can. Okay. So I have this 4 bar. Let me go ahead and label it. So we got 1, 2, 3, and 4. All right. So what you do is you label the obvious instance centers first. So I have one. So the obvious ones are the easy ones. So let me do those in green. So this is I12, use a different shade of green. I12, right here. This one here is I23. This one here is I34. And this one here is I14. So let me pause there and let you let that sink in. So the join of 1 and 2 is I12. The join of 2 and 3 is I23. The join of 3 and 4 is I34. And the join of 4 to the ground is I14. And notice how I put the subscripts that has the smaller number, I put that out first. Or I write that first. Okay. So what we do is we actually have this thing called a circle diagram that I'll go ahead and use. And so what you do on this thing here, first of all, I probably should calculate that the number of instance centers on this is 4 minus 1 divided by 2 equals, is that right? No, I forgot about this part. So 4 times 3 is 12, divided by 2 is 6. So I got 6 instance centers to locate here. Well, I'm more than halfway because I got 1, 2, 3, 4 already. So what you do is you put these tick marks to represent the links. And so we just evenly space these tick marks around this is called a circle diagram. Has no geometric meaning at all, other than just keeping track of these instance centers. So we label them 1, 2, 3, 4. And then what we do is whenever we find an instance center, we go ahead and make that line solid. We join the line between them. So this line right here represents I12. This one here, I23. I34. I14. Okay. Then what we do is we looked at how this thing works is from every link you need to draw a line to another link. Well, we have a line missing between 1 and 3, so let's go ahead and dash that in there. So if I take, so this means here that I'm looking for I13. And so what we do is we use I12 and I23 by drawing this right here. I12 and I23. We draw this line here. And then we draw a line on the flip side, 1, 4, and 3, 4. Like that. and where those two lines intersect is I13. That's applying Kennedy's theorem to this. I know I'm going fast because I'm out of time. So I make that dashed line a solid line once I identify it and find it. Then for the next one, I look at this here, and I see that I have a line missing between 2 and 4, so that means I go from 1, 2 to 1, 4. Okay, so I draw this line here. And then I draw a line from 2, 3, 3, 4, 2, 3, 3, 4. And where that line, those two lines intersect, that right there is how we locate I 2, 4. And we make that line solid. So this is I 2, 4. So what we'll do next time is some more mechanisms, but I want to at least introduce that topic to you. All right? So I'm over time. Happy to stay, answer questions if you have.